Welcome to Unit 3, Physicochemical and Therapeutic Incompatibilities. Our objectives for this topic are the following. First is to identify and classify various pharmaceutical and therapeutic incompatibilities. Second is to formulate a therapeutic plan. And third is to identify drug interactions liable to produce therapeutic incompatibilities. So our topic for today is divided into two main parts: pharmaceutical incompatibilities and therapeutic incompatibilities. Incompatibilities and drug interactions can happen throughout the whole medication use process, from the prescribing to the administration of medication. However, no harm will befall the patient as long as the medication was not being administered. That is why the pharmacy practice and pharmacists play a key role in reducing medication errors and incompatibilities by making appropriate interventions at each stage of medication use process. Interaction is defined as the thing that occurs inside the body that cannot be seen, while incompatibility is a problem which could arise when two or more substances interact during, before, or after drug administration. It can occur also outside the body, and incompatibility usually is visible to our naked eye. There are two forms of incompatibilities. First is the pharmaceutical incompatibilities, divided into physical, chemical, and pharmaceutic. The second form is the therapeutic incompatibility, which talks about drug interactions. Now, let us discuss the first form of incompatibility, the pharmaceutical incompatibilities. First, let's discuss physical. Physical incompatibilities is the interaction between two or more ingredients that leads to a visible, recognizable change, example in color, odor, taste, viscosity, morphology. Example of these are incomplete solution, precipitation, liquefaction of a solid ingredient, sorption, vaporization or volatilization, polymorphism, and loss of water. The first example under physical is the incomplete solution, or there is insolubility and immiscibility in the process. An example of this is a mixture from gum and alcohol, pectin and alcohol, resin and water, oil and water. The second physical incompatibility is precipitation. This happens when there is salting out process, where the solute, which is originally dissolved in solvent, is thrown out of solution. Factors affecting solubility involves solvent, pH, and temperature. Example under precipitation are the aromatic water and salt, spirits and salt solution, camphor solution, and water. Precipitation can be managed by knowing the property or the drug's solubility, so that you can use the correct salt or ester form of the drug. Also, you have to know or calculate the drug's pH to avoid ionization, and add solubilizers or co-solvents to avoid precipitation. The third physical incompatibility is liquefaction of solid ingredient. Examples of this are Deliquescence, Efflorescence, Eutexia, and Hygroscopicity. Deliquescence happens when there is absorption of moisture that dissolves the solid. Example is the sodium chloride. While efflorescence, on the other hand, is the release of water of crystallization. Examples of chemicals that undergoes efflorescence are the following: citric acid, atropine sulfate, ferric sulfate, and alum. Eutexia, on the other hand, is the lowering of melting point, and it occurs at room temperature. Components or chemicals that undergoes eutexia are the following: menthol, phenol, thymol, and camphor. While hygroscopicity is the property of the chemical to absorb moisture but does not dissolve. Example of this is the silica gel. So for liquefaction of solid ingredient, if it happens, we can manage it by storing our chemicals in very tight containers. Also substitute these chemicals that are prone to liquefaction into anhydrous form. We can also add adsorbent to this drug that contains components susceptible for liquefaction. We can also place our product in a low humidity environment and separate and protect potential eutectic mixtures. The next physical incompatibility is sorption. Sorption is a collective term for absorption and adsorption of drugs onto containers, IV tubing, devices, and closures. So sorption can be managed by shortening the contact time of the drugs and the containers. Vaporization or volatilization. This is the liberation of the active ingredient or the compounds with high vapor pressure. Example of this is nitroglycerin. Vaporization can be managed by storing our drug in tight containers and reducing the vapor pressure. Next one is polymorphism. Polymorphism is the existence of one or more crystalline and or amorphous forms of the chemicals or the drug. Example, for cubic form, we have sodium chloride. Monoclinic form, we have sucrose. Tetragonal, we have urea. Hexagonal, we have iodoform. Triclinic, we have boric acid. And rhombic, we have iodine. The next physical incompatibility is the loss of water. This occurs when there is reverse liquefaction. The dehydration due to extreme condition is also possible. So susceptible for loss of water are liquid dosage forms. Example are the emulsions, suspensions, solutions, ointments, and gels. So emulsion can undergo phase inversion in oil-water mixture. That is called cracking. For suspensions and solutions, if there is loss of water, there might be an increased potency. For ointments, it can result to crumbling, and for gels, it can result to syneresis. We can manage loss of water by storing our drugs in tight containers and storing it in correct conditions by adding also humectants. The second type of our pharmaceutical incompatibility is the chemical. Chemical incompatibilities have the following class: oxidation, reduction, acid-base reaction, hydrolysis, solvolysis, racemization, epimerization, precipitation, explosive mixture, cementation, gelatinization, polymerization, photochemical degradation. So chemical incompatibilities occurs when there's a reaction between two or more ingredients that leads to the change in its chemical properties. It can be a visible change, but not necessarily observed from the original drug. So oxidation. Oxidation is the loss of electrons, and it is a reducing agent. It also undergoes the process of dehydrogenation, and it can increase in oxidation state and trigger and light and metals. It manifests as change in color. Example for drug prone for oxidation are the ascorbic acid and epinephrine. This can be managed by protecting our drug from oxygen, light, or we can add antioxidants. We have to keep also oxidizing agents and reducing agents away from each other to prevent explosion. The next chemical incompatibility is reduction. There is gain of electron, and it is considered as oxidizing agent and can undergo hydrogenation. So there is decrease in oxidation state. An example of chemical that is prone for this are the reducing sugars. The next chemical incompatibility is acid-base reaction, where neutralization occurs. Therefore, evolution of gas can be observed. For example, in effervescent tablets, by adding sodium bicarbonate and tartaric acid. Also in para-aminosalicylic acid. In acid-base reaction, there can be observed change in color. Hydrolysis. Hydrolysis is involving water as solvent and breaking up the bonds of water. This is the most common type of incompatibility. This is the most common mechanism of drug degradation. Examples of drugs that are prone to hydrolysis are the beta-lactams, penicillins, and cephalosporins. Esters or ester containing such as cocaine, physostigmine, aspirin, tetracaine, and methyl dopa. Amides, imines, and glycosides. So hydrolysis can be managed by storing our drug in tight containers. We can also add desiccants, a component also that can control pH, and storing our drug inside the refrigerator. Solvolysis. Solvolysis is interaction of drug with solvent other than water. Racemization is the action or process of changing from an optically active compound into a racemic compound or an optically inactive mixture. Racemic mixtures is about equal amounts of dextro and levo isomers. For example, our thalidomide, catecholamines, and local anesthetics. Epimerization. This occurs when epimers are formed by the two compounds that has chiral centers. There will be interconversion of one epimer to another epimer. An example of this is the tetracycline and pilocarpine. The next one is precipitation. There will be salting out process that occurs between two or more drugs interacting to form new substance, a precipitate. So an example of the formation of calcium carbonate and water from the addition of calcium hydroxide and carbon dioxide. Next one is reducing agent and oxidizing agent when combined together form explosive mixture. Specific example is sugar and potassium permanganate, glycerin and potassium permanganate. Next is cementation. Cementation is the formation of cake from acacia and bismuth salt. Gelatinization is gel formation forming from acacia and iron salts. Polymerization is the formation of polymers from dextrose. And photochemical degradation is degradation by light and manifests as change in color.